Hello, welcome to ISAT 211, Issues in Modern Production Systems. This is lecture 11, Lean and Six Sigma. Well, in this lecture, we're going to talk about the Lean principles, the history of Lean, and also some of the common use tools in Lean, because Lean is a very important concept in managing manufacturing systems in order to improve the efficiency and make efficient use of resources. Well, first of all, Lean really started from the Toyota production systems. As you may have heard before, that Toyota production systems, it started from the Toyota. And then, in order to improve the efficiency and reduce the cost, they developed a set of tools and also philosophies to manage their production systems, to reduce the waste and also to sustain the high quality of production. And the link here is the history of Toyota production systems. You should please watch this movie, watch this video, and get an idea of the history of it. Well, so Lean basically has several concepts, and there are five major principles. And basically, these are the five terms you need to understand. The first one is the value. Understand what is the value. Value is defined by customer's needs. So basically, what the customer is willing to pay, right? For example, you buy a product and then you're okay with paying the material of the product, and you're okay with paying the production activities, right? Like the worker is operating on the machine, right? All these activities are okay. You're okay to pay, but are you willing to pay for the worker, having a rest or having too much rest? It's okay to have a rest, but if having too much rest or a lot of idle times, are you willing to pay for the breakdown of the machines? And you probably don't want to pay for that. So if something that is you are not willing to pay, that means the activities that is happening on the shop floor, there is no non-value added, right? So understand what is value added activity and what is non-value added activities. So if you draw, a picture or draw a map of, all these value-added and non-value-added activities, you will start to have a better visual map of what is happening on your company operations. So that is called a value stream, right? That is called value stream. And so the concept of flow means we want to make the parts run. Because the parts, actually that's where the money is at, right? You pay the money, you get the materials, and also you pay for the production processes and also the operations. If all this money is actually embedded in the parts, in the material itself, if you let those parts sit on the shop floor and wait for a long time without moving, it means that the money is not moving, right? If the money is not moving, means it cannot generate benefit for you, profit for you. Now think about the case that if you have a constant cash flow, which means that you can frequently finish the production process and then sell the product, you get a benefit. Then you can use all these benefits to maybe increase your production or buy the new materials that are coming in. So which means that in 1 week, maybe you can make 1,000 parts or 1,000 products and generate maybe $1,000. If you let the part sit on the shop floor without moving during the 1 week, maybe you can only make one part over the week, and then the profit you can generate is also very minimum. So that's why we want the parts to flow instead of sitting on the shop floor or we stack a lot of inventory. That's what it means by flow. Make the parts flow. Another concept is a pull system. A pull means that we the production activities is only triggered by the customer's need, right? So that's a pull system. pull system is it's the opposite word for push. So in the past, what happened was you have a lot of raw materials. Now you just start to produce, right? Until you finish all your raw materials. But maybe you made 1,000 parts, and then you can only sell maybe only 100. So which means that there's 900 of products that you can now sell. As I just mentioned before, all these products are at where your money is at, right? Where's your investment money is at. And if they cannot be sold, which means that you're not getting your money back, you're not getting the profit or your revenue. And this is why the pool system is invented, that we only start a production based on there's a need. So if we think that their need is maybe 100 next week, then we only prepare enough materials for the 100 products for next week. In this way, we can actually reduce the inventory and also have more cash on our hands, and so we can invest in some other activities for more profit. And the last one is perfection. So perfection means we want to make this lean thinking and continuous improvement as a corporate culture. So this lean thinking means, we always start to think, where are these wastes? Where are these non-value added activities? And how can we improve? How can we solve problems? Right? So the concept for continuous improvement is that there's never a perfect, right? So we can always find ways to improve our process. Whenever there's a problem, we start to organize the team, analyze the root cause, and then figure out a solution and then implement it and keep it as monitoring, constantly monitoring the production line and what's happening. We increase the quality of the process and also the product. So this is a perfection. So in lean, there are 7 types of waste. Typically 7 types of waste. You can also add another one, which is unutilized people. And you should watch this video, understand what these 7 types of waste are. And so in the waste term in lean, usually we actually use another term. It's called MUDA, M-U-D-A, MUDA. Let me see if I'm right on this. Sure, it's give it a try. It's 10. Okay. It seems I cannot write on this. I'll figure out how to. No. And all right, it's MUDA, M-U-D-A. So MUDA means waste, and it is a Japanese word, because in Japan they started to build a production system and these concepts. And so that's why there are some terms that we directly borrowed from those Japanese words. We use MUDA to represent the waste. You may want to remember this term, because in production companies, this is going to be a very common term you will see in companies. And another 2 terms will be MURA and also MURI. So MURA means unevenness in productivity and quality, and MURI means overburden of machines, managers, and production associates. This. Okay. All right. I just talk a little bit about the pull system. The pull system there's also another term. It's called just in time. So just in time means we make only what is needed when it is needed, right? We probably don't want to store a lot of raw materials or store a lot of parts if they are not needed at a certain time, right? Otherwise, we'll have to find place, and there might be some costs for storing those. And that's why you probably want to have all these parts or materials only arrive at the right time when it's needed and only in the amount that is needed, right? This is a pull, and there's a so when we're talking about the pull system, and a lot of times that if we only store or only have what is needed for production itself, then sometimes there may be certain risks because maybe there are some scrap parts, or sometimes there may be some delays for arrival, or some risks. And in order to avoid those problems, or if those problem happens, we still need to produce, right? So that's why we can still design a certain amount of the inventory that is not very high, at a very low level, in order for, but we can also minimize or reduce the risks of low stock, out of stock, or delayed delivery, those kind of risks. So that's called leveling. So it means that smooth production needs with a certain amount of inventory. And so people started to create that kind of a level pull system, which is a mix of a pull and level system to utilize both the advantages of these two concepts. Another term here is one piece flow. So one piece flow means we when we are doing the batch production, there's a lot of waiting time for other parts in the batch to be finished. And so that's why we probably want to reduce the batch production to a certain size, right? To a certain size that is more efficient, because every time you change a batch, there will also be a setup time, right? Since think about production time and the setup time. If each setup time is all different, or you make the setup too frequent, which means that you're still gonna spend a lot of time doing all the setups, and that won't make it too efficient. Well, the one piece flow does not mean that every time we only make one part. Well, in some production companies or in some type of production, maybe it is feasible, but mostly one piece flow is talking about reduced batch size to short or changeover times. And the Kanban, so Kanban is a concept basically to to practice the pull system, how to how to do the pull system in production companies. Kanban means visual signal or visual card. So what it means, how does it work is you can actually watch those two videos to give you a better concept of this. But basically, what it does is you put all your our current level of inventory, or not. Here we don't call it the inventory, but mostly we call it the Kanban. How much Kanban do you have? And it may include the part number, the description, the supplier, and pull to, or who is using it, and also what is the amount, right? Especially the amount or the quantity, right? Or the level of the Kanban. So what it means is, say for your operation or for your process, your production activities actually triggered by the information on your Kanban part. So for example, you are storing about 10 parts, right, at your process, and every time we will see the 10 parts value is reduced, say your 10 parts value today is reduced to 5. Now you know that, okay, today I need to make 5 parts to make up this difference, right, in order to reach this 10 parts level. What happened that triggers those the Kanban level from 10 to 5 is actually from your next process, because the next process receives receive the order saying that, okay, we need to make 5 parts, and then the next process directly get the unfinished parts or from your process, right? You finish your parts at your process and you have 10 inventory, and then the next process directly get all these 5 parts from your inventory, and then he can start to make. So it means he does not have to wait for a long time until you finish all of those. He can get directly from the inventory. Well, if you see, your inventory got lower, then you can start to make it until you reach the command level again. And then how do you make those into 5? You directly get the materials, from your prior process, right? And then start to make it. And the prior process will be like you, and then see, or his command level also reduced the source to a certain level. He got the information that, okay, he needs to make the difference again. So this is how this information is actually transferred or passed across the processes, and using this kind of a flow or using this logic can really do the pull system in production companies, and it also it proved it's very efficient. And another concept is Jidoka. Same, watch this video. So Jidoka basically is to try to eliminate or find out where are the defects, because when a defect happens, you first need to figure out what caused those defects, where are the problems, trying to detect the problem, stop it, and then fix it, and then investigate what is the root cause and maybe implement a solution. So this is it's more of a quality control process. And Pogoyoki means it means a mistake proving. So it's a skill or it's a technique that to avoid simple human errors at work. For example, you can design some of the fixtures trying to reduce the mistake in positioning each part here and there. And so little tricks or little techniques like that, it can be called Pogoyoki, or you can also design, for example, if you are designing a human computer interface and some buttons, how can you arrange all these buttons so we can actually make to reduce the possibility of human errors in operating your interface. And you can watch this video for to look at one example. And another tool people already use is Toyota Total Productive Maintenance, TPM. So TPM focusing on the equipment itself, right? For example, to break down the equipment, how to prevent the equipment from breaking down, and how to fix it or correction, and also how to maintain the equipment, because not only how but also when to maintain it, because if you only try to fix it after it's something happened, that means that you actually can shorten the equipment's life. Think about your HVAC, right? If you don't care about it at all, if you do not do those in a regular service, maybe you can only use our HVAC for 7 or 8 years. But if you can do this in regular service, maybe you can use all the equipment for 15 years. So that's this is how you can, in Toyota Production Systems, they develop this whole set of activities, practices to maintain and to do prevention of the errors or problem or breakdown of all these equipment. So it's called Toyota. It's called Total Productive Maintenance. And for continuous improvement, typically we do this PDCA cycle. It's a plan, do, check, act. So it means plan means planning out what resources are, criteria, and also limits. And do means observe and collect data. So collect data means you understand what is happening on your shop floor or what's happening to your production quality. And then check, if everything is happening according to your plan. and then figure out how to improve it next time. So keep doing this cycle, and this is how you can practice a continuous improvement. And then next concept is the Six Sigma. So Six Sigma, there are actually different ways to understand it, and people may refer to this differently. For example, in quality control, and Six Sigma is actually talking about how what is the probability of the defects in your production, right? And you can draw a normal distribution table. For example, like this, draw a normal distribution table, and the Six Sigma is really talking about how many the defects you have, right? How many defects you have. This part will be the defect, and this part will be defect, and all these parts in the middle are actually good products. And we know that middle here, right? This is the mean, and here is how many sigmas away from the mean, right? This is the mu minus n, say n sigma or h sigma. Let me see. It's not very easy to draw it this way. Say n sigma, okay? And this is mu plus, okay, plus n sigma. All right, and sigma, and this n means how many sigmas away from the mu. If the Six Sigma, we can tell that it's actually a very small number for that. I think it's how many zeros after zero after the decimal. I can't remember exactly, but that is very. I think some 1 or 6 or something in 1 million defect parts of the probability. And that's about, this is where you can refer to the Six Sigma, is talking about the probability of defects in production. Another way to understand the concept of the Six Sigma is actually more of a quality control program, right? Quality control program means when something happens and you actually can start to do the make process. The make process means define, measure, analyze, improve, control, to improve the quality of the quality of process, or to solve a certain problem. Define means define the problem, see what is happening, or define what is the symptom and what is the problem, the statement. And then measure means how do you measure the quality of the process, right? And you can develop certain metrics to measure it, and also set up certain standards, which means which is good, which is bad, and which is a normal state, and then analyze the data based on the current situation of the process, and also come up with a solution, right, to improve it. And then after that, you come up with a solution, you improve it, and then you start to do the control, right? Make sure it's monitor and control the process performance is always within your the range of the quality tolerance, right? So that is the make process: define, measure, analyze, improve, control, and so in a lot of companies, they actually have they form those Six Sigma teams, or even Six Sigma department, trying to use this process, or use Six Sigma concepts to do continuous improvement or to quality control. And also there are different certification programs for Six Sigma. For example, you get a yellow belt, green belt, and black belt for Six Sigma, and those kind of certificates has been being very useful when you're looking for continuous improvement, or manufacturing engineer, or operations engineer jobs. All right, so that's all about today's lecture.